Problem number 1, find the area of the region bounded by the graphs of y is equal to x squared plus 2, y is equal to negative x equals 0, and x equals 1. So to find the area, let's sketch the graph of the given function first. So we have y is equal to x squared plus 2. Okay, so let's sketch the graph of this function. Oh, and let's say this function is equal to f of x. Let's just name it that way, okay? You will be using the specific name of the function later. So since this is a quadratic equation, it means the graph is a parabola that opens upward, where the vertex is at 0, at the point 0, 2, because of this. So let me just draw the parabola here. There we go. Yeah. Okay. So this is our f of x, and the second graph, or the second function, is y is equal to negative x, and let's call this function to be g of x. So let's sketch the graph, and it is the equation is linear, and the slope is negative. Therefore, the graph is falling from left to right. So let me sketch the graph, and it looks this way. It passes through the origin. Okay, and let me just put some details. Okay, here we go. So this is our g of x. Okay, so which is equal to negative x, and the parabola above is equal to x squared plus 2. And it says here that the boundaries will be coming from x equals 0 and x equals 1. So let's identify these boundaries, or these vertical lines. I have, okay, so x equals 0, that's here. X equals 0. Oh, let me put it. Okay. Oops. And so this is the x equals 0. And the other one is x is equal to 1. And let's say that 1 is here. This is x is equal to 1. So this is our 1, and this is our 0. So in this case, it should be extended. This one should be extended here. So let me fix it. Oops. Oops. Okay. So all right. So let's assume that it intersects the graph, or the point. The graph intersects here. Okay. And this is the region that we're trying to get the area from. So this area. And okay, let me just shade the color. I mean, shade the region where the area is going to be identified. So let's use this one, something like that. Okay. Now again, for us to determine the area, of course, we need to use the rectangular strip, right? The vertical rectangular strip, and let's identify that here. So let's assume that the area, I mean the rectangular strip, it can be found somewhere here. So let me use another color, green. Okay, so let's say our rectangular area is here. It's here. And here we go. Here we go. Something like this. Okay. And let's identify the points. The point here. Okay, let's say this is our x sub I. All right. So if this is our x sub I, now this point is what we call the x sub I and g sub x sub I. And this point here is x sub I and f of x sub I. Why? Because this point touches the f of x, while this point below touches the g of x. Okay, so we have already identified a rectangular strip, and this is just one of the infinite number of strips that we will be, or that we have here in this region for us to calculate the exact amount or exact value of the area of the shaded region, right? And of course, we need to identify the width of the rectangular strip here. The rectangular strip's width is change of x or delta x. Okay, so, and this is our height or the length. Okay, and let's identify the parts. So the change of area is equal to the length times the width of the rectangular strip, the representative rectangular strip. Okay, so we have the length is equal to the difference of the heights, the difference of the y's of the 2 points. So we have, since we need to get the distance from the lower point to the upper point, we have f of x sub I minus g of x sub I times the width of the rectangular strip. So which is change of x or delta x. So this is now our the representative of the area I of the rectangular strip that we made here. Okay, so with the use of Riemann sums, this could be expressed as the area is equal to the limit of the summation of the areas of all the rectangular strips. That's f of x sub I minus g of x sub I times the change of x, since the change of x or delta x are all equal in all the rectangular strips here, where I is equal to 1 until n, and as n approaches infinity. Infinity. Okay, so we need to have infinite number of rectangular strips for us to actually measure the actual area of the shaded region. So this is now our representation of the area using Riemann sum. And again, we could convert this into an integral notation, okay? So based on the theorem that we discussed before. So that's area is equal to the integral of f of x minus g of x, okay, dx. From, of course, we're going to start from 0 to 1. 0 to 1. And we use 0 and 1 because we use vertical rectangular strips. Okay, so with respect to x, that's why we are using the value of x of the figure. Okay, so the intersection of this g of x in the x-axis, and also the intersection of the x is equal to 1 and the x-axis. So that's the boundary, okay? Boundary of the region. So this is now our working equation to find the area of the shaded region. All right, let's go to the next board to solve for the area. Okay, and let's just copy our integral notation or the working equation that we had. So, sorry. So that's the integral of f of x minus g of x dx, or with respect to x from 0 to 1. And let's substitute the value of f of x and g of x. So that's, we know that f of x is the quadratic equation x squared plus 2 minus g of x is the negative x, or the line that is falling from left to right, and with respect to x from 0 to 1. Okay, so we're now ready to integrate this expression. So we have, or let's just simplify the expression. So copy, so x squared plus x plus 2 with respect to x. And let's integrate. We have x cubed over 3 plus x squared over 2 plus 2x, and to be evaluated from 0 to 1. So this is now our the integral, okay? So let's now evaluate this. So we have, oh, let's use the other, okay. So we have here, let's evaluate. We have, let's substitute 1 first, okay? Based on the fundamental theorem of calculus, number 2, or part 2, we have 1/3 plus 1/2 plus 2 minus, and everything will be 0 here because the value of x is 0. Okay, so let's go to the next step. We have, let's add. So the LCM is 6, so this becomes 2 plus 3 plus what, 12. And this becomes 17 over 6, 17 over 6 square units. So this is the area of the shaded region, or of the region bounded by the curves or the graphs. All right. So it means that this area here is equal to 27. Okay, 27 over 6. Okay. So I hope everything is clear. Now, since you already found the value of the area here, now I want you to answer this problem as well. Okay, so problem number 2, find the area of the region bounded by the graphs of f of x equals 2 minus x squared and g of x equals x. And this problem will also be, we will be solving this problem on our next video, but try to solve this and let's see if our answers will be the same or equal. Okay, and bye.